Hello everyone, Andrew Chubb here again for Awale Resources, TSXV ARIC. I'm just coming here to you with a webinar on our induced polarization survey and the commencement of drilling on our 100% Awale Fremen target, which is pretty exciting stuff for Awale. It's the first drill program that we've had on our 100% ground. We've said that 2025 is going to be a big year for Awale, so without further ado, let's get on with this discussion. First up, a quick locator. We are again on the Odiani project. This release is concerning our 100% Awale ground on this Fremen target down here, which is 4 kilometers along strike from the BBM discovery. Today we announced the fact that we've finished the IP over the Fremen area. We've got about 5 kilometers of IP there, and that survey is continuing off into the joint venture. And that, you know, pretty much as soon as we got the initial imagery from the IP, we've confirmed that there is a coincidence in anomalism, and we've sort of started to head off on our scout drilling program. So just a quick recap on those previous releases around the Fremen target and the BBM share as a whole. So we're down here on the Fremen target. We've done IP, which covers down over these geochem anomalies that we announced, and as I mentioned, the IP is continuing along up this shear for in total about 150 line kilometers. So we've completed roughly 50% to date up here towards where we've actually been doing our recent drilling at BBM, and we announced some results for a bit over a week ago. And so now, as I said, we've commenced drilling on the Fremen target. The IP survey is ongoing toward the northwest, and we have 2,000 meters of planned drilling down here at the Fremen target. Induced polarization, or IP, is the geophysics that we just did. We're looking here at a chargeability map, and then superimposed on that in red is the gold footprint from the BBM target, which you can see the box here is where we have been drilling and all the announcements we made on BBM. And we've got an anomalism all the way along the shear, which we can trace out in the IP. There's a step over, and it continues down here. We use the resistivity and the chargeability and other derivatives to define that contact zone, and we can also see out here that there is another contact zone between a resistivity and chargeability target, and coincident with that there is also some gold anomalism. So you can see that we've got a drill line there over the highest order part of that target. You know, we're really looking, we're ready to extend these programs if we need to, but these are initial scout lines to understand the geology and see what the chemistry is subsurface. So I've tried to line the next image up as best we can. So we're looking at the chargeability here, and then the next image is the resistivity, and you can see that if I actually pop there is a nice coincidence between the resistivity and the chargeability, and this is something that we look for, particularly with the BBM, with a BBM analog targets in mind, in that we get quite strong silicification of the rocks at BBM, which creates a higher resistivity, but then we also get sulfide accumulations of over 3%, which also creates chargeability anomalies. I've got a final slide that just talks a little bit about IP, and I'll give you a bit of a summary about what I'm talking about there. And the other picture that we can see here is the float that we picked up in outcrop or subcrop down here in this zone, and I can tell you that this float from this zone looks like the highest strain rocks as we move towards mineralization at BBM. So we've seen some. There's not a lot of outcrop. It's very limited, and even this sample is actually what I would call float or subcrop. It hasn't moved far. It's from a large piece. But it's showing that we've got similar geology down here to what we've seen in our drilling up here on the BBM target, where we've been reporting those nice results over the last 12 months. And so we've got coincident resistive chargeable anomalies, and which is good thing. It is similar to what is at BBM. So we're running the scout drill lines now. You can see there P1, P2, P3 and P4. They're the 4 planned drill lines, which will be a series of holes or fences of holes across those that test those targets down to a depth of, the average depth will be between 80 and 100 meters of each of those holes. So really exciting stuff. First drill program on 100% Awale ground, and look, there will be more to come as we do more work on our 100% permits. So I told you I'd just give you a quick summary of IP. Now we've been talking about resistivity and chargeability. So IP, what we do is, well, what the subcontractor does is they've got an equipment that pumps a high voltage current into the ground. Depending on how deep you want to look, it might be between sort of 300 to 500 volts up to say 3000 volts. And what we do is, so that's represented by this red circuit here. And then inside that red circuit, we have sort of receivers which measure over distance the voltage between 2 points, and that voltage that we pump into the ground, we turn it on and off. So you get a time delay, which is like a battery. So you charge up the rocks and then you turn the current off, and then they decharge. And the longer they take to decharge means the more chargeable they are, and the more potential that there is for sulfide accumulation. And so once you get more than sort of 3 to 5% sulfides like pyrite and chalcopyrite, not all sulfides work perfectly, but chalcopyrite and pyrite are generally pretty good. Pyrite being very good, you get chargeable anomalies in the ground. The resistivity is how resistive those rocks are, so that the current takes a long time to pass through the rocks, the current that you're pumping into the ground. And this resistivity is very helpful in mapping subsurface geology as well. So when you've got the better you've got a handle on your geology, the better that you can interpret that sort of resistivity. But that's what we're looking at when we do an IP geophysics survey. So in summary, thanks very much for that 8 minutes or 10 minutes of your time, and we're really looking forward to seeing what comes out of the ground in this 2,000 meter program at Fremen, and we'll definitely be reporting back to you when we're finished that program and we're getting the samples off for analysis, etc. So exciting stuff. Thanks very much.